Okay, we're going to, in the next couple of videos, finish up tolerances of profile. Tolerances of profile because they can cover, complex features and bound, weird shapes and control all aspects really of geometric control from form and orientation and position. They can be very complex, and one of the complexities that you'll see with profile, and you'll also see it with orientation, is the concept of a composite control, where we can control aspects of features individually, and then at the same time control those features as a group. And I'm going to try in this first shorter video to give you an example where that would be useful. It's a little bit easier, I think, to see before we get into the feature control frames and all of that. And unfortunately, as I've said several times, the standard uses some terminology that's pretty cumbersome, pretty clunky, and this is probably the perfect example of where that terminology just gets to be almost ridiculous. But it serves a purpose, so in the next video we'll talk about that. What I want to do here is introduce you to the concept of a composite control, where we're going to look at features individually and control them individually, but at the same time we're going to want to have a different set of controls if we can consider them as a group. Now where would be a scenario like that? I want you to think of like a piece of sheet metal here that I've drawn on the board, and that piece of sheet metal is just a cover. It's just going to cover up the side of a machine frame or something like that, and these holes are punched in or lasered in, water jet in, however they're done. So there's a fair amount of clearance. But still in all, we want the holes to line up with the tapped holes in the frame that they're going to, we're going to bolt up to. This is a common enough problem in manufacturing where the tolerances don't really add up properly, and you might find that you can't get the bolt in the last couple of holes. So how do we control that in GD&T? We use a composite control. And we look at these clearance holes. Let's say these are clearance holes for a quarter 20 screw to screw this sheet metal cover onto a frame. So what our primary concern here is that the holes as a pattern are fairly tightly spaced. So that the spacing between the holes from one hole to the next is fairly tight. Doesn't have to be crazy tight, but we want it to be consistent. We want it to be a fairly close tolerance of the features within this pattern of 8 holes. Once we've done that, let's say that we make a punch, a punch and die set that has 8 punches located in it. Each one of those individual punches are positioned very precisely so that we know that we have a good tight grouping of these holes. And when you take this piece of sheet metal, you put it in the press, it comes down and it punches all 8 of those holes. Well, the spacing of those holes isn't going to change. The spacing is going to be as precise as the tool that makes them. So the production of the spacing of the holes, or the pattern of the holes, is fairly precise. But let's think about it now. If we have this piece of sheet metal and we put it into the press, it really doesn't matter too much if that pattern shifts over a little more than the spacing of the holes can tolerate. So if that whole pattern is produced all at once, if the sheet metal's a little extra wide, or if it isn't bumped up against the stops correctly, you could get that whole pattern of holes shifted over a fair amount. Would that affect anything? Probably not. We would still be able to take that piece of sheet metal and line up all the holes, because the spacing of the holes themselves is controlled by a different process. It's controlled by a precision punch. So, what we have then is this scenario where we've really got two different things to control. We've got the individual spacing of the individual features, and we want that to be fairly tight. Let's say, I don't know, plus or minus 5 thousandths. We want each one of these hole spacings to be whatever they are, plus or minus 5 thousandths. So fairly tight, but again, well within the production tolerance of a punch. Once we've got that under control, once we've got the hole-to-hole spacing under control and tight enough to guarantee that when we line up with a pattern of tapped holes on the frame, all those bolts will go in. Then we can think of, each one of these holes as a separate feature. And that's where we have the tight tolerance. Then we can think of this pattern of 8 holes as another feature that can have a bigger positional tolerance. So the entire pattern, as long as it moves together as one, whether that pattern shifts a little more one way or the other, up or down, left or right, really doesn't matter. So we have this notion that as long as the features within a group are individually spaced tightly, that the pattern of holes that they form can actually have a larger tolerance, and that is called a composite tolerance. And what we use to control that in GD&T is kind of a strange looking feature control frame that will have a single, as it always is, the tolerance symbol or the control symbol is always in a box by itself. So we would have, say, a profile tolerance. In this case, I wouldn't use profile, I'd actually use positional control, but the idea is the same. We have one large single symbol box, and then in these two boxes, we define the tolerance that we want for the hole-to-hole spacing from one feature to the next. And then we use the other box to control the holes as a pattern rather than as individual features. And what you're always going to find is that the pattern locating tolerance is generally going to be larger. So the larger tolerance will be up here. So let's call this the pattern control. And we'll call this the feature control. So the individual spacing from hole to hole is the feature tolerance, and it's going to be a small number. We said 0.005. Actually, if we're going by that plus or minus 5, we would say 10 thousandths. The pattern then could shift, I don't know, a 1/16 of an inch without having any real effect on it, as long as the hole spacing from one hole to the next is this nice tight tolerance. We can put a much larger tolerance on the pattern, so that the tool that punches all of these holes has to be fairly precise. That's not super precise, but you get the idea. Once that's done, then we don't have to worry too much whether that pattern shifts a little bit. How would it shift? Again, as I said, if you're bumping up against stops and your sheet metal's a little bit bigger or smaller, that will shift that pattern. If there's a burr on the sheet, or if the guy just doesn't bump it up properly, that can shift this pattern. What it won't do though is change the spacing from one hole to the next. So much material, especially in a production environment, is produced this way. Is you might set up a drill head to drill 20 holes all at once, so that the feature-to-feature tolerance is very tight. That it's all set by that tool, and then we put the piece of material in there and we drill all those holes at once. That feature spacing isn't going to change. What can change and has the potential for having a wider variation is where that pattern is located to a part. A lot of automotive parts are made this way, especially the sheet metal portions of it. All those features are produced at once. If you've ever seen the way an engine block is made, there's a single machine that comes in and drills all the bolt holes for the head, let's say, in an engine block. So the feature-to-feature control is tight, and the pattern then can be a little bit looser, or quite a bit looser in this case. So anyway, that's the idea of a composite control, where we have a pattern tolerance and we have a feature tolerance. The feature tolerance is almost always going to be tighter, and the pattern then is allowed to float a little bit more than the much tighter feature tolerance. I've used these terms, the pattern control and the feature control. Those aren't the proper terms. In the next video I'll explain what the proper term is. It's very cumbersome, and they actually shorten it up into a couple of little buzzwords. So the next video will explain that. I'll explain how it'll actually look in the feature control frame and how you would evaluate it. But keep this in mind, is that the upper one is going to be the larger one. It will be for controlling the position of the whole pattern, and the lower one is for controlling the individual elements within the pattern.